Good morning. Welcome to the fourth day of the summer school. How are you feeling, people? Very energetic. I'm glad to see that. Today we'll start with a very, very exciting lecture. At least for me, it's a dream come true. Somebody will tell us how we could use the ChatGPT large language models for rapidly annotating and analyzing our research data, something we have spent a lot of time earlier. Months were spent on manually annotating some data or training the large language models. But Andres Karjus will talk about his experiments in that field, what we can do with zero-shot LLMs. So Andres Karjus is a very multifaceted researcher and a linguist and an artificial intelligence specialist from the University of Tartu, University of Edinburgh. And he's also a very experienced teacher, a tutor. And for the first part of today's lecture, we'll start with the lecture. And you're welcome to ask your questions right away. When you have them, please raise the hand, ask your questions in Zoom chat. I will try to go to you and give you a microphone. And then after approximately 1 hour and a half, we have a short break. And after that, we will continue with the practical session. So let's go. Andres, welcome.
Yes, thank you very much. I have my own. So hello, my name is Andres. I'll be talking to you about artificial intelligence as Anders said, how to automate yourself. Right, so yes, I did study in Edinburgh and Tartu, but I'm from in the sense that I'm based in Tallinn University and also the Estonian Business School, and I also operate in the private sector as a private consultant. So just a couple of words about myself, why I do these things sometimes, and how I ended up here. So my background is indeed one part linguistics. I started out as a Finno-Ugric linguist, and then my second master's degree is in AI and natural language processing from KU Leuven. So I've been doing this sort of multidisciplinary language and cultural science for a while. I'm just about to finish my postdoc at Tallinn University at the Cultural Data Analytics Open Lab. So besides linguistics and then mostly corpus linguistics, I've been doing various things like art history and network science of film festivals and history of television broadcasting and various colorful things. Besides that, I'm an instructor and a consultant. I've been doing workshops on various digital skills. Previously, more in the realm of statistics and data analysis and data visualization, including here. This is actually this photo, a couple of years ago. But in the last, I guess, year and a half or so, almost 2 years soon, I've been doing more courses on generative artificial intelligence because apparently there is, for some reason, a huge demand for courses like this. But these courses have been more geared at, let's say, people like teachers and professors and government office workers, but also in the private sector, various people. I've given courses to both translators and also people who sell used cars. But these have been more geared at the sort of how to use these large language model powered chatbots, which are of course very easy to use. I'm sure you have as well. I mean, who here has used this thing at least once in their life? Probably almost everybody. And of course there's a number of these things now which work rather similarly. But this is not today's topic. Today's topic is rather the language models themselves, which I think is something extremely useful for people like us who do research on large textual data, large image data, and so on. So over the last, since ChatGPT came out, so basically since the GPT 3.5 model was out, there has been a growing mountain of research on how to use these models to do various computational natural language processing tasks faster and easier and with less effort. These are a few good starting points, especially the Zeems et al. 2003 paper, Can Large Language Models Transform Computational Social Science? And what most of these papers do is they show that, yes, you can take this model and solve a natural language processing task faster, because now you don't need to train, because these pre-trained large language models are powerful enough that you can just literally tell them what to do. Instead of doing a sentiment analysis of, training a sentiment model for every single language that you have, you just ask a language model, is this sentence happy or sad? And it works. It works very well. Because they have been trained for this sort of instructions, to follow instructions, to be used as chatbots. But incidentally, that also makes them useful as, sort of research assistants. So this is the zero-shot part. So zero-shot here refers to the paradigm of basically doing a task without being trained for it. So until very recently, the dominant paradigm in machine learning was supervised learning, where you take a model, you could train a model from scratch, or you take a pre-trained model. In humanities, lots of people use this like BERT-type previous generation large language models. And then you train it for a single task, like sentiment analysis or some sort of annotation or whatever. But now you don't necessarily need to do that anymore. You can just ask. And that is, of course, awesome, because often as researchers, we have lots of questions, and training a separate model for every single question. And of course, humanities and social sciences are very complex. The topics are complex. So often, to answer a research question, you need to, annotate a ton of variables. And now you don't need to train a model for every single one of them. Of course, this is not new. People, as I said, have been doing that for a while, just using supervised learning. And what I'm trying to contribute as one part of this lecture is a framework where you use all this annotated data. Because there's loads of this literature, like these wonderful papers, which show that it works. Here's the task, here's the accuracy score, it works. But now what? Okay, so we know it works, but how do we actually integrate this in research? How do we go beyond the sort of, we annotated some data, hooray? How do we go beyond that step? And this is also something I see a lot in digital humanities still, is that people are happy with just to run a model or annotate some data. It's like, we did it. Okay, but now what? And I'm going to try to answer the now what. So basically, how to get the most use out of these machines. Of course, since there's all these hype bubbles around AI, maybe a few disclaimers. So what we're talking about here is not some magical divine AI that has descended upon Earth. These are just next word prediction machines. They were and they still are. Turns out, after half a century of AI research, the best way to get AI is to predict the next word. That is a bit of an unsatisfying answer, but that's just how it is. But yeah, so if you train a model to predict the next word, and then especially if you tune it to follow instructions, then you can use it for things. And big enough models can sort of kind of reason. They're still predicting the next word, but they do something that looks a little bit like human reasoning. So it's an emulation, but it's close enough for many tasks. They don't. So that's a paradox. They don't know anything. They just predict. They know nothing, but also they know enough. But importantly, yes, the topic here is not how to use ChatGPT today, although I have a ChatGPT-based solution prepared for those who are not very familiar with programming, just in case, but rather how to use models programmatically. So how many of you can write like basic little bit of Python or R? Give me a wave. So I have like okay, so somehow you're like, you're auto-divided yourselves into groups already. I might need to mix these groups up a little bit. But don't worry, if you haven't programmed in your life a single line of code, then it's fine. I have examples, and I have examples where you don't need to run any code. You can still do the practical part. More disclaimers. So yeah, I see some problems in this AI discourse, especially when I talk to teachers. People sometimes regard AI as this sort of divine entity. And like, yeah, I heard there's AI. Can you bring AI to our company? But again, it's rather just specific models doing specific things, not anything monolithic or mystical. And there is no magic button. So as a consultant, I often get requests for a magic button. People turn to me and they're like, yeah, I heard there's all this awesome AI, and like, can you bring some AI to us? And then they give me a description of what they want to do, but it sounds like they want to press a button and then go for a coffee break and come back and everything is done. We're not quite there yet. Sorry to disappoint those of you who are hoping to completely automate their jobs, but we're getting close. And of course, there's this weird misconception that AI equals ChatGPT. I've heard discourse like, yeah, I heard this AI version 4 is much better than AI version 3.5. Again, just one of many models. Anyway, so part of this lecture follows and is based on this preprint that I actually put out already last year. It is in review. It's going to come out in a journal as well soon. But it's on archive, so if you want to read it, it's there. But the version that will come out soon, hopefully, is much more updated. So basically, it's a method proposal, how to use this capacity to annotate things very fast in a research framework. So a lot of humanities do something like this. And I'm not claiming that any of this is new. It's just a proposal to use something that is useful and works in this context. So people come up with a research question. And there are various paradigms where people do some sort of schemes for coding variables. Is anybody here doing content analysis, for example? Is that a thing? Yay. Discourse analysis. Again, similar things. And there's a thematic analysis and something else analysis. And then collect some data and hopefully unitize it, not always, make it into units, and then do some sort of coding, put some tags or some markers on text or images or something like this. Unfortunately, this is where many people stop, although you shouldn't. And they just say, oh, look, here's like a bunch of these codes and a bunch of these codes, and I think that tells me something. I mean, you should go on, and then if you have quantized your data, then you also need to quantify, which is in most cases entails running a statistical model and doing your interpretation and reasoning based on that, not just looking at little codes. But this pipeline essentially is something that is very common in linguistics, in corpus linguistics, usage-based linguistics, these sort of paradigms, where it has been refined, I think, to a point where I think it's a very nice, neat, clean paradigm. I think it's just useful. It might be useful for other humanities fields to just adopt that because it works. And I think it has clear advantages over previous paradigms, including content or discourse analysis. But why I'm bringing this up here is that I think it's pretty much a perfect paradigm to use machine assistance in, to use large language models or any other capable machines. Because you have this explicit coding step, this quantization step, where you take qualitative data like, let's say, free running text, and turn it into, for example, categorical variables. And this is something where large language models are quite capable. They can do that. So you can consider them as assistants, basically. So let me make a little example here. Oh yeah, by the way, if you have any questions, then just ask like immediately. You have a question immediately. Also, if there's questions on the Zoom or whatever online thing, then feel free to just ask right away. And yeah, if you see it on the chat, just tell me.
Yes, it's a small question, but very important, especially about what you're talking. So, is it what you're saying is that people doing qualitative research and just hand coding their text annotating, they're not doing something enough, and that they should quantify and do something with machines? I just wanted to understand. It seemed to me like you're saying that you should not stop at this stage, although from practice I have seen that sociologists, anthropologists, they stop there.
Yes, because they're methodologically not very good sometimes. No, you don't need to use machines. Machines are for scaling, the way I see it. Like if you have 10 examples, then you don't need a large language model to code them. You can just do it yourself. I think machines are good for scaling. Machines are not smarter than us yet. But yes, if you have quantitative data, then you need to use quantitative methods. If you use a paradigm where you take your qualitative data like text and you turn it into some discrete categorical variables or numeric variables or whatever, then that's quantitative data, and you cannot, you shouldn't apply qualitative methods to quantitative data. It should be, use the thing for the correct thing. If you're quantitative data, then you need to quantify, which in most cases means using a statistical model. Otherwise, you run into various problems, which I will get into as well. More questions?
So I have a question about this sentiment, critical, supportive, neutral. Where does this classification come from?
Just an example I'm going to explain right now.
Because there is also this type that positive, negative, neutral, etc. So it depends on the
Don't think too hard about it. I just made it up.
Okay.
Yes. Any more questions? Okay. Just if you have any questions, just ask right away. Okay, so here's an example that I just made up in my head, just to give you an example of how this pipeline works. So let's say my question is about the topics and sentiments, or maybe my hypothesis is that, I don't know, political topics in certain newspapers are more critical and sport is more, supportive, let's say. So that's my research question. That's my coding scheme. In that case, would be one variable is topic, the other is some sort of sentiment. I need to unitize. This is, again, sometimes I see a lot of people don't think much about unitization. They just talk about, oh yeah, I analyzed this book or something. I think unitization is quite important, especially for the statistical part later on. So think, what is your unit? Maybe, let's say here in my case, there are sentences. So that means I annotate every single sentence for these two variables, topic and sentiment. And this is the part that can now be done by machines. This is something that used to take humanities and social science researchers tons of time. I've heard discourse, people saying like, how many examples is a PhD? How many examples of annotated is one paper? Like, oh, should it be 1,000 for a paper? I don't know, 5,000 for a PhD. This is like a unit of work almost. And of course, since we're dealing with these very complex cultural and social phenomena, often it's not 2 variables, it's sometimes 20 variables. So this takes a lot of time, but it can now be done by machines rather handily. Of course, you shouldn't trust machines. Never trust a machine. And this is why this part is important. You should have an expert annotated, and you're the expert, annotated test set, so you can quantify the errors of the machine. And then you can also incorporate them in the statistical modeling, so that if your machine is not very accurate, you will take that into account when you do your statistical model, so that you don't accidentally make too strong, too confident claims. And once you have done your coding, then you run your statistical model. Here it could be something like a logistical regression model, for example. And then you interpret the results, and then that's your test of your hypothesis. Can't skip that. I know that many humanities disciplines, like I see a lot of content analysis that just kind of skips that, or they just count the variables or something. Don't do that. That leads to bad things. So here's a actual real example. So this is from a recent paper of ours. So we worked on this corpus of Soviet-era news. We actually have the whole videos, but you also have this sort of synopsis, which have been annotated before. So for each little story, it's these news things that news clips that they used to show in cinemas before films in the Soviet era. And for each clip, there's a synopsis. Here's a story about, I don't know, some guy who drives a tractor in this wonderful, heroic kolkhoz. And we tried to do this kind of a large language model-driven topic modeling here, where first our expert historian came up with a number of topics. So here are these keywords, but each of them has a longer description specific to the Soviet period. And then we used these GPT, I think here was GPT 3.5 and 4 models to just annotate every text. So the text goes in, actually have that's the prompt that gets sent to the API. So classify this news text with a one topic tag, use only one of these tags. Here's the definition of politics, military, and there's like, I think, 8 or 9 topics here. And then there is some text. The original is in Russian, but here's a translation. Some memorial meeting in the Bolshoi theater of something, something. And it works. The accuracy, we get these, where is it? Something like 85%, I think it was. This is something that would take a professional historian, I think we actually calculated, yeah. It would take about 19 hours of work just to read through them. And of course, you annotate again, so basically a week of work. On a large language model API, you leave it running for like an hour and then you're done. With a rather high accuracy. So here the scheme, the coding scheme is topics. The unit is the story synopsis, for each story. And then it was quantified using a regression model. And there are also these error bars here. I'll come back to that later, but basically you can easily quantify, you can incorporate error. So it's not 100% accuracy. Accuracy meaning agreement with the historian's test set. But you can quantify that, and then you can put these confidence intervals around your time series or around your regression coefficients and so on. This is already out in Humanities and Social Science Communications, if you're interested in historical news. I mean, we also do a bunch of other things in the paper. Right, so a quantizing machine-assisted design, if you will. But of course, for many of you, this sounds probably familiar, right? As I said, this is necessarily not new. Combining machine learning and statistics is not new. Combining human annotation and statistics is not new, especially in linguistics. And variants of these combination of qualitative and quantitative analysis go by many names. I mean, it's kind of mixed methods, but I've talked to mixed methods people who say it's not for some reason. But it's been called various things, like integrated mixed methods is something actually very similar. Integration through data transformation, converting mixed methods, which all somehow combine the qualitative analysis and then some sort of quantification. In digital humanities, distant reading is very similar. So, but often there you operate with rather counts of topics or counts of words or something like this. And of course, there's content discourse and thematic analysis where you do some manual coding, but the quantification tends to be quite limited. In linguistics, this has also been called a number of different things. Basically, this pipeline is super common, but there is no single name for it. And sometimes it's just called analysis, because it's such a default way of doing things in corpus linguistics. It's also been called multifactorial usage feature analysis, or variants thereof, but also behavior profiles by Greece. But what I like about this sort of pipeline, and why I think it's useful, and I think could be more broadly used in humanities, it has this explicit steps. Unitization, coding, qualitative annotation, and then this rigorous quantification, which there has been quite a lot of literature on how to do that. So you don't need to reinvent any wheels. And it is, I think, very well suited for machine-assisted science because you have this explicit annotation step, where you can just plug in either research assistant students or you can plug in the machine. And I think it might be useful to conceptualize using these large language models or similar powerful machine learning models as assistants. Especially if it's not just doing basic things like counting words or something. Because that makes you think that, okay, so I have an human assistant, maybe the human assistant is not very good, maybe I should check on their work, maybe I should compare their results to mine. And this is the same mindset I think you should have if you use these large language models. Being pragmatic, I don't see like a particular reason for the continued usage of methods like discourse or content analysis on large data sets when you have more systematic, rigorous alternatives available in the form of this sort of feature analysis or quantitizing methods. I also find it hard to find arguments for the application of purely qualitative research anymore. I mean, if you're really doing small data, like a one person or one book, and the book is a unit, then maybe not. But otherwise, I mean, why not combine your qualitative insight with large data? And in the past, the complaint in Humanities was that, oh yeah, but like, qualitative analysis is so complex, so many variables, like we cannot do lots of data because, human time is just limited. But that is not an argument anymore. You can absolutely scale your expertise now. Of course, not every scenario requires scaling, but many benefit, and data is more and more available. Why not make use of all of the data? Instead of limiting yourself to small samples, make use of all the data. But replacing human functions, human coder or analyst functions with machines requires machines that actually work. So the question is, are large language models good enough for that? Especially for complex tasks in small languages beyond maybe English. Yes?
It's again a small but important question. If I understood correctly, you said that accuracy of this machine algorithm would be 85%.
For this particular task,
yes,
according to this particular test set.
Okay, and then I'm thinking about my real life and meeting humanities researchers, and what they sometimes want is 99% accuracy. And so I'm thinking maybe it's about different cases, about different scenarios. For example, if you have a large data set and you just want to learn what's in it, then 85% is really good because you can skip 1 week of work. But if you are making a corpus you want to publish somewhere, usually I meet humanists who want to have almost 100% accuracy. I guess you also have met people like that. And I think also for some purposes like library catalog, it should be close to 100. 85 would not be good. Could you maybe reflect on this?
Don't know where the question... I think the answer to your question is yes. I mean, yes. Sometimes you want to be accurate, but also you should probably ask what is the ceiling of your actual possible accuracy. So this example with the Soviet newsreels was a good example, actually, I think, for us when we were working on it, because we discussed these results with the historian, and we came to the conclusion that probably 100% is not even possible between humans, 100% overlap, because you have these... I mean, I can scroll back there. You have these short texts which mention often even in a short text you have multiple things. You can have, I mean, is this politics or is it a cultural topic? Or you can have, I don't know, this is a story about this guy who drives a tractor, but he is also a Soviet war hero. But also he is a sports champion, because of course he is. What is the topic? So So if you ask different people to annotate this data, you probably won't get 100% agreement also. So I guess the suggestion or advice here is to just think also about your question. Is it a question that actually has an objectively correct answer? Or is it more of a slightly subjective? And a lot of humanities is subjective, and I think that's fine. But what is important, but often missed in humanities, is you should probably quantify that disagreement, either between humans or humans and machines, or machines and machines. You should have an idea how bad is it? Is it like, oh yeah, sometimes we disagree, but mostly we're on the same page? Or is it like, you say white and I say black, completely different things always? I think keeping an eye on these disagreement rates is important.
Thanks, that was helpful.
Right, so where was I? So the question, like, are machines good enough? And these tests I ran actually already like a year ago, and the machines were good enough already back then. And of course, again, there's a lot of this literature. I'm not claiming novelty here, but a lot of this literature testing these large language models and various tasks is focused on English, and very clean, modern-day, perfect English. Whereas I figured, okay, maybe I should try something else. So I tried, like, I think there's like 9 languages here, and also data that is intentionally bad, like just broken. But still, these accuracy scores are mostly from the GPT-4 model, which was current at the time when these tests were run. And most of these accuracy scores are like pretty high. Like it works, and these are not easy tasks, most of them. It failed a little bit on a very difficult task in Latin, where also humans fail. I spoke to the author of that original study. Turns out it is a very difficult task. But yeah, it works. If you're interested in this stuff, that you can check the preprint. I have a few examples here. I'll kind of just walk through them a little bit, because I think, yeah, I have time. To give you an idea, like what you could do, maybe give you some ideas. So linguistic feature analysis. So this is basically where this is the paradigm that I think is useful to borrow. So I also took a linguistics paper where something like this, again, of course, not calling it linguistic feature analysis, basically something like this was used. So it's a paper on linguistic value construction in advertisements. So they use this newspaper corpus from the 18th century, and they annotate if an advertisement, or rather the phrases describing the sold items in advertisements are rather something like objective or subjective. So is it like, this is a red carpet, or is it's a very good carpet? And it's a rather long paper, and they clearly have done like rigorous work, but also a lot of work. Like you can see that a lot of work went into the paper, and they discussed the annotation process and how they did it again and again, and probably took like a lot of time. So I figured, okay, could we automate this? So I took their phrases, the phrases that had already been extracted from the advertisements, and I ran GPT-4 just with a basic prompt of like, is it a subjective or objective evaluation of this, whatever there is. So here the coding scheme is just one variable, descriptive and subjective. These are the values of the variable. Unit is a phrase, and then this can be quantified using regression or to test differences or whatever. And the accuracy is 94%, or a kappa agreement of 89. So, and that takes like minutes, and you get accuracy that is close to human experts. And here the human experts are these authors. I just took their data, so I knew what they said, and I just compared that to the machine. They also discuss about agreement between themselves in one stage of the annotation process, and their interhuman agreement was 84. And machine to their final assessment agreement was 89. What else? Here's another linguistic task. So this is a replication of the semantic change detection task from the SEMEVAL 2020 unsupervised lexical semantic change detection. task, which was at the the conference is Semaval, yes. So basically, there are two tasks. One, the ground truth is a list of words. In one task, you just have to predict, has this word changed over time? They had like 3 or 4 languages, and they gave example corpora, and people trained various complex models to predict, has a word changed in meaning? And then the other task is like a graded task, like here's a list of words in order, from most to least changed, and then the comparison is like, do you get the same ranking? In 2020, people tried various models. I mean, some are this old school word embedding based, some are this contextual, like BERT based. But turns out you can get very good results also just with jar-shot GPT-4. So this is the binary task. In English, it gets to very easily to the level of the best model in Semaval. So the x-axis is number of examples. So how I did it was just feed examples from this example corpora, just sentences, and ask, has this word, is the word different in meaning between these two sentences? And if you give it like 10 or 20 examples, then in English it gets to state of the art, just by asking, no training, nothing else. In German, it's above random, but not very good, and in Latin, this just doesn't work. Apparently not enough Latin in GPT-4. In the graded task, so this is the ranking, it's very easy to get above the best model in Semaval, and also this dotted line here is a paper from 2022, which also applied a large language model framework, and it's a quite dense paper, clearly a lot of work went into it, and it's easy to get better results than that in English. In German, the results are kind of in between, and again in Latin it doesn't work. But the effort that goes into doing these specialized architectures is clearly like you write an entire paper about it, whereas with a generative large language model you just kind of just compare some sentences and you get a similar result. Something else. So I also tried lexicography because I don't know, why not? So here the task is synthetic, so I just generated some examples in English, Turkish, and Estonian, because I figured you have just 3 different language families. And it's a sentences contain this nonce word. So in that case, it's bear, glue, thief. And the task is open-ended in that case. There is no coding scheme. The model is presented with a sentence like, I don't know, something something climbed a tree in the forest. What is the something something? And then the model, it usually takes only a few examples. That's again the x-axis to guess that, okay, this is this word. And this is not a question of, is this a thief or a bear? It's literally an open-ended, what is this nonce word meaning here referring to? Bear is the most complicated because it just confuses it with other large animals. What else? Text and idea reuse detection. So this is something people do in history and I guess also digital humanities. Is anybody here doing that, by the way? Text reuse detection. So basically the idea in that field is that there are ideas that travel between texts. Often people use newspapers, and they want to see how either ideas or literal copies of texts have traveled through different newspapers over time. So I again tried a little synthetic task here. I again turned to our historian in our Kudan group for ideas. So I used this concept from one of their papers, which dealt with pseudo-historical ideas in Russian online forums. And one of these pseudo-historical ideas is that Russians descend from the Huns. Yes, that was it, which is not true. But this is something that circulates. So I just took this idea and then tried distorting it. So rephrasing it, introducing this sort of OCR errors, so make the text broken, translating between English and Russian, and then all of this together. So try to mess this text up. So here's one example of of an English synthetic generated sentence, and then translate in Russian, broken with OCR. I mean, not OCR, but like that looks like broken OCR, swapping letters out. And the accuracy here is 100%. With all these distortions, the model correctly detects if this idea is present or not. Which is pretty good, I think. You can do not only text reuse, but also idea reuse detection. Here's the dataset I acquired from the Estonian Maritime Museum. It's a dataset of shipwrecks in the Baltic Sea. So what people have been doing over decades is, they literally dive in and look for shipwrecks. And this has quite a few. I think it has like 500. No, it's quite big. Quite a few hundred shipwrecks over. I think a few hundred years, but most of them are like last 100 or 200 years. And they have these little stories attached to them, written by, I think, mostly one person, like ages ago, which are sometimes very short, like, this ship was sunk there, or sometimes it's super long. It's like, this is the story of the ship, and then it went down, but then it was, I don't know, these people found it, but then it was lost again, and it was like very long. And the task is here, which they already did, they tried to annotate like the reason of the shipwreck. So I tried to do that using GPT-4, and I get 88% accuracy. I mean, I made the set a little smaller in terms of the types of wrecks, but basically it works. So what in the past required this sort of maritime expert to look at the story and think, okay, so what is the actual reason here? And of course it's complicated because sometimes there are multiple reasons. Can now be done with a machine with reasonable accuracy. But of course here again, accuracy means agreement, and sometimes even humans don't agree because the story can contain multiple reasons. Does anybody here do interviews? Anybody interview researchers? Yes. Okay. So people do interviews. Often they're semi-structured interviews, and then they have a lot of text, and then they think about them, these texts, and then do some sort of analysis, and it varies which kind of analysis. Here's, again, this is a synthetic example, so I generated some interviews about online learning, so it's as if they were interviews with people, students saying what they think about online learning. Here's an example sentence like, one of the things that bothers me about online learning is it's harder to have those spontaneous moments of laughter and fun, something. And then I try to predict, again, using GPT-4, if a given statement is positive or negative about online learning. Do they like it or not? And it gets easily 100% accuracy. And also in the preprint, this is used as an example of how to apply a regression model. So if your hypothesis is that controlling for age students living on campus see more negative aspects in doing assignments online than those off campus, then you can easily test that using a regression model. You can put confidence intervals around your predictions, basically. So instead of just reading your interviews and thinking, I think people are more like this and people are more like this, but social and humanities phenomena are complex. You want to control here, for example, for age. You want to control if they're on campus, off campus, and maybe other things, maybe gender, other things as well. And the human mind cannot really think in many dimensions. We're good at thinking in like 1 or 2 dimensions. We cannot think in 10 dimensions. And each variable is a dimension. But you can easily, if you use statistics, then this becomes super easy. Yes. What else? So then the next question is, how do I find my examples? Either in interviews or books or newspapers or whatever your data is. Maybe you're interested in, let's say, I think here's the, So this is a replication again of a paper by some good friends of mine in Tartu, who studied this large newspaper corpus of English language texts. No, actually, in this paper, I think they had other languages as well. and they're interested in mapping major continuities and ruptures in industrial modernity, but basically how people talk about nature and industry. But this is English, by the way, not Irish or something. The newspaper corpus they used is horrible. So the OCR is really, really bad. Even as a human being, I mean, this is one of the worst examples they showed me, but there's a lot of that as well. I mean, some is fine, and then some is like this. And even as a human being, I mean, what the hell is there? Like, can you even tell what is there? But they tried to annotate this data anyway, try to figure out what's there, and try to find examples of sort of nature discourse. So I tried to automate that, and they sent me a little test set, which they had used themselves to evaluate. But we figured, let's try something. So why don't we ask the language model to do sort of a zero-shot text cleaning? And this is the cleaned version here. It might hallucinate. Like maybe it sees something there that was not there originally. But we can test that. We can run this relevance detection task. So basically the task is this sentence something about nature or not? And if we run it on the original and we run it on the cleaned set. And if the cleaning makes it worse, then we can see it in the accuracy because the task score will be lower. Turns out this is not the case. Cleaning helps. Yes, it might hallucinate a little bit, but in the end, it helps and it raises the score. So for GPT-4, with cleaning, the score gets to 92% accuracy or 0.82 kappa agreement. This is quite good. So again, a lot of work can go into like finding your example. I mean, they used some sort of combination of, I think, regular expressions and topic models and keyword expansion and whatnot to even find these examples in this massive corpus. Or you can just use a large language model and just ask, is this example relevant for my question? Yes, no. Is this next example relevant for my question? Yes, no. And so on. Again, all of these examples are from the preprint, so you can look into details there. Here's another replication of a paper by Oleg and Artyoms, who I know very well. So they did this sort of clustering of literary genres, and they tried to just play around with different pre-processing methods, different clustering methods, also different embedding methods to see what is the best combination. Again, a lot of work clearly went in there. But since they use this ARIM metric, which is something you use to measure cluster correspondence, this is mathematically equivalent to kappa. So I figured, okay, why don't we try zero-shot literary genre detection? So here the scheme is genres. I think there were like 4 genres in there, or 5. You know, like crime, fiction, romance, and something like this. The unit is passages, because I just broke these. They send me also the text, so I broke the text into parts and fed the parts, just passages of text, into GPT-4, and asked, is this, okay, classify the genre of this fiction text. Here's the text. And I to save some money, because the API costs money, I just only classified on like 25 segments per book, and it gets a higher kappa score than their best combination of pre-processing methods. But here there is no pre-processing. You just feed in the text, and it works. So you don't need to deal with lemmatization or cleaning of stop words or any of that stuff anymore. Here's another thing I did just for fun based on that. So I tried to classify 2 texts. One is The Android's Dream of Electric Sheep by Philip K. Dick, and then the movie adaptation, which is called Blade Runner, and just put them side by side because, I don't know, I like both of them. And also use pretty much the same coding scheme, but break it into passages for the text, the book, and then into scenes for the movie. It's just the script of the movie. And you can easily, I mean, this takes only minutes, and you can compare literary works. I mean, this is an example with genres, but of course you can do it with anything. You want to compare, I don't know, violence or love or whatever in different books or different adaptations or whatever. It's super easy. How much time do I have? Okay, so we've been going for like an hour now, yeah. A few more examples. So I'll get to more practical things also soon. Something I discussed with a literature scholar at my university, if we could do this sort of translation analysis. So here I took the first chapter of George Orwell's 1984 in English and in Italian, because the guy I spoke to is in Italian, so I could check the output. And this is an open-ended task where I just basically aligned these two translations using a tool called BERT-align. It works actually quite nicely. And then the open-ended task for GPT-4 was just analyze it. You are now a literature scholar. Analyze this translation pair and tell me if there's something different there or something has been translated differently. And then I gave it to two Italian people who are both literature people and just asked them, like, is that okay? Like, what do you think? What's your assessment? And basically for all 74 pairs, they said it's basically perfect. This is what I would say as a literature scholar. I also tried, and this is something again in the preprint, to kind of work out some sort of more quantitative way of doing that, so sort of a semantic edit distance, if you will. So maybe it's a little bit technical to go in here. So basically generated examples of English and Japanese text, but then changed little things there. I added something, replaced something, or deleted something. And additions, deletions, and replacements. This is how edit distance. Wait, do you know what an edit distance is? Maybe I should have started with that. So edit distance is how you measure distance or similarity between texts based on just characters. And it's based on usually counting deletions of characters, additions, and replacements. So it doesn't take into account semantics. It's just this very fast algorithmic way to compare text. This is also how a lot of plagiarism detection works, for example. But it doesn't take into account semantics. But now you can use large language models to do semantic edit distance. You can ask how many things have been added here. Has something been removed? Has something been censored, for example? And it turns out it works quite well. I think I can't remember, for Japanese, I think it was also near close to 100% accuracy. What else? So this graph might be familiar to some of you. It's the character network of Les Miserables characters from the book. It's often used as an example in network science textbooks and also network science kind of programming packages. So I tried to do the same using GPT 3.5, just feed in the whole book sort of passage by passage, and the prompt is list all the characters that interact in that passage. And this is another quantified result. There is no accuracy quantification here, but I get something of a network that looks quite similar. But it also has all these side characters, of course, which this manually constructed example does not. So you feed in a book, you make yourself a cup of coffee, and you have a network. Again, there might be some errors there, but you can go back and check every example what the rating was and see how it worked. So imagine now doing that for much larger data sets, not just one book. How about 1,000 books, 1,000,000 books? And again, this is, I also looked into how long it would take. So assuming sort of average English language reading speed, which is 228 words per minute, if you're interested. And if you also take notes of characters, it would probably take about 2 weeks of work to go through the entire book and note down all the character pairs. Or you can do it in a few minutes. I also calculated the same for a corpus. So who has used the Corpus of Historical American English, or COHA? Has anybody made use of that? It's a very nice corpus if you're working in English. It covers 200 years, and they really tried hard to balance it between 4 genres. So it's kind of sort of representative of American English. But of course, what people do is they just extract examples, for whatever grammatical or semantic phenomena they're looking for, or just feed in their entire corpus into a machine learning algorithm. Nobody goes through the corpus and reads it, like line by line, or nobody does an entire analysis of the corpus because it's about 400 million words, which would take you about 14 years to read through, which is a bit much. But for a language model, it's not. You feed it in and let it read through it and make notes if you want, or analyze, or whatever your research question is about the last 200 years of American English. There's also now these visual language models or multimodal language models. When I was writing that last summer, this was still a bit new. So these are like pretty basic examples. I probably either remove or update that part actually there. But turns out you can train language models also on images, and they become capable of reading images, including things that were considered very difficult until very recently in computer science, including understanding stupid memes or recognizing like what is doing what to whom on a picture, or also recognizing objects in non-standard artistic images, for example. For these large language models or multimodal models, this is actually quite easy. And most of these state-of-the-art models are now multimodal. This includes GPT-4 onwards, so GPT models, the last Claude family of models, so that's the third generation. What else? Gemini is now multimodal. But then you have also these smaller open source, or the open weights models, which are much smaller, but are also multimodal and actually work surprisingly well. And I have an example of that down the line here. But here's an example. So something we did, again, with the newsreels data. So this is what it looks like. It's black and white, very grainy, and the resolution is 300 by 200 pixels. This is not a lot. It's super bad digitization quality. And it also has this like stuff overlaid. And I asked my colleague again, what could we do that would be difficult but interesting? And immediately she said, give me all the Lenins. I want the Lenins. So I said, okay, let's try to get all the Lenins from. So there's hundreds of hours of this footage. Watching all of that would take a lot of time. But the sort of presence of Lenin is quite important in Soviet history. How Lenin was used to, for various propagandistic reasons and whatnot. But of course, Lenin can appear in many forms. You can have the real Lenin. You can have Lenin as a statue in the background. You can have a big Lenin. Or you can have Lenin, this is Lenin, this is about 10 by 20 pixels or something here in the background, but he's there, very importantly. And of course, in the past, you could do this object detection and say this is a human face, but that's not really useful. So with supervised learning, you would need to train a Lenin classifier. There's a bunch of pictures of Lenin in all these various forms, and then a bunch of pictures of not Lenin, and then try to classify. But you don't need to do that anymore. You can just use these instructable models. So here the prompt was pretty easy. So we did it in 2 steps, and this is still ongoing work, actually. But the initial test set results are here. So the coding scheme here is it linear or not? The unit is one extracted scene. So a scene is like a frame, but we removed we took 1 frame per scene using scene detection. So the prompt is find anything Lenin-like. Does this image potentially contain some depiction of Lenin? So this is the first prompt to get rid of all the things that are definitely not Lenin, but you can have a lot of false positives in there. And this is something we did with a local model that we run on just a very beefy local computer, no cloud needed. So first pass is run all the, I think there's 250,000 frames. Run all these frames. I mean, originally, if you take 1 frame per second, it's millions and millions, but we reduced it using scene detection. Get all the pictures that could be Lenin, and then feed it into a stronger model, in that case, GPT-4, and then ask, okay, so is it actually Lenin? And if it is, then is it the actual person, or is it some artistic depiction? Yeah, question?
Regarding, if you could just go back to the previous slide regarding this Lenin example. So as I understand it, since this is a generative model, the output was no, it's not, or yes, it is, and don't say sorry. So then you had to sort of recode that into what you wanted the answer to look like. I don't know, 0 or 1 or whatever.
No, the answer is yes or no. That is the answer.
Yes, absolutely. But my question is, could you have asked the model to give you that information, or was it really like what was the output format like? Did you get a table?
Yes or no.
Sorry?
Yes or no.
Yes or no, right. But could you have asked the model to give you a table where this information was already present in? So I'm going to give you 10 examples, and you're going to give me a table with the examples and the answer.
We tried it with various other tasks. It's possible if you want to save some money, because of course if you use an API, most of these services you pay per token, so pay per word basically. So sending for every example, every sentence, or in that case every image, you send in the same long description of, okay, here's what you're gonna do. Then of course it gets costly, and one way to save money is to just have one prompt and then 10 examples. But this degrades performance quite fast, it turns out. So, I mean, these are still next word prediction models. So yeah, right. If you say, okay, here's 10 examples, give me a list where this corresponds, they get confused. Newer models are better. So GPT 3.5 got confused after like 10 examples easily. GPT-4 is a little better. Yes, you can use that as an optimization strategy, but so far, the best results I've always gotten when it's one prompt, one example.
Okay, and the do not say sorry is a way of tweaking it into really saying a binary response. Yeah.
So I'll get back to that. So you kind of can treat it as a not very intelligent research assistant. You need to tell it what to do. There is a way, especially it's super easy with actually GPT models on OpenAI API to constrain the output to certain words. It's just when we ran that particular prompt, GPT-4, the Vision API endpoint did not have this parameter to constrain the output. So I had to say, don't say sorry. But actually, if you can constrain the output, I get back to this, it's using the weight bias, then you don't actually need to say that. But in general, yes, you need to instruct the thing what to do. It cannot read your mind yet. So these are the results. So this is recall and precision. In our case, we wanted to maximize recall in the first pass. So we get like everything that could be Lenin, and then we give it to a stronger model. And here is what performed really well were these actually two very small models. So we ended up using Lava 1.5 for the entire set, because it's only 13 billion parameters compared to like hundreds of billions for the state-of-the-art models like GPT-4. You can run it on if you have like at least one A100 chip somewhere, then you can run it locally. And it got 100% recall. So did actually Moondream. This is surprising because this is tiny. Like, imagine like this is the model, that's Moondream 1.86 billion parameters. Like this is Moondream, and then this entire room is GPT-4, and it works. Apparently, this model has seen enough Lenins. Precision is of course not great because there's lots of false positives, but this is fine because then we give it to a stronger model, and it can solve it. We could of course just run everything immediately through the strongest model, but that is a bit costly to run 250,000 images through the GPT-4 API. But of course, if you have a few hundred, or well, it depends how much data you have. But if you have a few $100 just laying around, then you can actually do that. You don't even need to bother with smaller models. Just throw everything into the strongest model possible at the given time, and then just whatever. We also tried these YOLO models. This is YOLO model. This is a sort of a loose family of models for object detection. In the past, it used to be a fixed set of objects, like 72 COCO classes that you could detect. With YOLO World, it's now also zero-shot in the sense that you can define your own classes. But this, I mean, also it's tiny. It's less than 1 billion parameters, so it's tiny model. But even that, I mean, it does sort of okay, but not really what we need. You can do fun things with that though. Like for easier tasks, it's super nice. Right, so this works. So to summarize this part and now move towards the practical part. So this sort of feature analytic quantitizing approach makes these steps explicit. It combines best of both worlds, I think. So you have detailed qualitative analysis, but you also have rigorous quantification, and then you can do uncertainty estimation. But this sort of approach has been so far bottlenecked by the human analysis step. For every example, you annotate all your variables, and it takes lots of time. But now you can use large language models, which are huge air quotes, but smart enough to do many tasks, including in humanities. And also, large language models can be used to replace otherwise complex computational pipelines. They are quite robust to variation and distortion, so you don't need to do necessarily any more things like lemmatization and cleaning and all of these steps. Again, it depends how good a model is in a given language. For English, it's of course, these models are quite good, even the open source models. For smaller languages like Latvian or Estonian or Lithuanian, things get a little bit complicated, and I'll get to that. Topic models is one example of what we have now argued in these two papers, which you can basically replace. Topic models were never really good. They're good for only if you do exploratory stuff. So if you really have no idea what's in your corpus, and you want to get these like vague topics of like, oh yeah, there's stuff here and there's some stuff here. If that is really your point of starting point, then sure, use topic models. But otherwise, it's not good because it's clustering. It doesn't matter if you use something old school like latent tertiary allocation, or if you use a large language model-based topic model, which there are out now. There's like things like BERT topic and whatnot. It's still clustering, so it's not suited for confirmatory inference because it's still clusters. You don't need to do that anymore because now you can do theory-driven topics. You define your topics and then you classify. So instead of clustering, you classify. So you can actually directly test your hypothesis. Of course, yes, there are problems with using these large language models, but I think most of these can be mitigated by just following good open science practices. But so far I've been quite optimistic about these things, but it's not as rosy, maybe, as I made it look like in the last hour. So before the break, so we have a little break in like 20 minutes. So there's also coffee there. We can have a little stretching break. But I'll maybe get to the trickier parts now. Problem number one, copyright and data protection. So there's a lot of this discourse, again, especially when I talk to teachers and educators, is that, yeah, but like we heard that you're not supposed to give data to the AI, to the chatbot problem. And it is kind of a problem, but it's not a chatbot problem. It's not an AI problem, but rather a cloud service question. So when you use these cloud-based models, either ChatGPT or like language model running in the cloud, you talk to it through the API, you're sending your data to the cloud. Maybe it's a cloud in Europe, but in most of these cases, it's a cloud somewhere in the States. And the question is, what can you send there? Can you send, for example, copyrighted data? Can you send people's private information? So if you did an interview with somebody, can you send that data there? It's a tricky question, but it's definitely not an AI problem. It's just, I think what has made it and kind of look like an AI problem is that all of these companies that are vendors of these models like Google or OpenAI, they also train on data, and they have been accused of just doing this sort of robber capitalism and scraping everything and training on it. So people are wary because they know that they might use, maybe they will use my data to train their model or something. Of course, I mean, one option is to trust the provider. As they say on their terms of services, if you use the API, they don't train on the data that is sent through the API. So they promise. You would never know if they did. Of course, I mean, there's also a question to your probably institution's legal team and what is actually private data. Like if it's just names, I mean, names can also be anonymized, but if it's names, I mean, does that make it private? And of course, what people seem to forget is that everything is running in the cloud. I mean, your email is running in the cloud. If you have a Windows computer, then by default you have OneDrive there, which you probably have activated because you logged in, so it is automatically putting all your documents folders into a cloud somewhere. Maybe you use Dropbox intentionally. If you use Apple, then things get backed up in the cloud. You use your phone and everything goes in the cloud. So, yeah. Of course, another option is to don't use cloud services. Run your own model on your laptop, but then it turns out, well, this laptop cannot run a very strong language model. If you're a gamer, or if you have a child who is a gamer, then steal their laptop, because these things run on graphics cards. A beefy graphic card can run like a small language model now, but not the most powerful ones, of course. And of course, then there's option for institutions to buy this sort of large, beefy graphic card hardware, but these things are very costly. I mean, one A100 chip, which is like the standard thing used for these things right now, which can run you like a small, medium-sized model, costs about anywhere between $10,000 to $20,000. Another option is to use a private cloud. That's an option. So a cloud that you do trust. So in Estonia, for example, we have the ETAIS, the Estonian Research something cloud compute infrastructure. So it's local. It's literally computers in Baltic and Tartu University. So we, in principle, can use that. It's not big enough for training. I mean, these large language models, if you want to train one, then you need like tens of thousands of these chips. The Estonian ETAIS, for example, in total has 50. In Tallinn University, we have this box in one of the offices that has 4. And I'm not sure if we should have bought that, because it's very expensive. There's also the problem that, yes, you could run an open model. There are a bunch of these open models now, literally hundreds of them. You could download it and then run it on whatever hardware or cloud is suitable. But there is no GPT-4 class model, as far as I know, for Estonian and probably also not for Latvian. If you have found one, then let me know. So these are primarily trained on stuff scraped from the internet. So that's mostly English. The Chinese models are mostly in Chinese. And then sometimes smaller languages are trickled in there. The fact that GPT-4 and also ChatGPT works on Estonian or Latvian is a coincidence. I mean, equally probable like alternative universe could be where there is no ChatGPT or Gemini or Copilot in Estonian and Latvian. It's a happy accident that they scraped enough data, the sort of pirates that they are, where there was enough of these small languages. So could we train our own models? In the past, we could. Like, I mean, smaller language models, let's say Word2Vec, people would train on their laptops, no problem. These things are more expensive to train. It's literally tens of millions of dollars to train them. So this is a bit problematic. But what you could do is take an already present open model that has a little bit of language, of your language in there, and then like continue training it on your data, which, there is data. Even in small countries like Estonia or Latvia, you have libraries where there is text data. Books, newspapers, textbooks, whatever. There are some companies, I randomly spoke to somebody from Cohur, which is, I think, a French company. And they're happy to actually train a model for free if you give them the data, but if you make it open source. But this is a problem because this data cannot be open sourced often. Copyright. This is something I've been discussing also in Estonia with various representatives of the Estonian Language Institute, the Language Technology Program, and like 3 different ministries. And everybody are like, but copyright. Well, maybe we cannot use it. But it's a bit of a gray area. Do books under copyright, does copyright apply to training large language models? In the States, they're actively litigating this and arguing in the courts. Here we are 2 years behind in litigating that. I mean, somebody needs to figure this out, because this is not just a question of humanities, but a question for economy. Like the economy of these countries cannot stay competitive if we don't move forward on this. Just because, I mean, if you have in competing countries, if things can be automated and here they cannot be automated, then there are some options though. You can just switch to English. Switch all your, for example, if you're a company or an institution that wants to automate your, doing your memos of your meetings and protocols and whatnot and press releases, which is something people are very interested in the government sector. Just do your meetings in English. Fine. Then you can run your own model. There are plenty of options for English language models and automate everything. But of course, in small countries, we don't really want to switch to English, maybe. Maybe we want to keep speaking in our own language, at least in some contexts. Then another option is to use machine learning. Machine translation. Sorry, there's a typo here. So there are machine translation models also for Latvian to English, and then you use an open model like Mistral or Llama. But of course, then you introduce distortion. You make it a noisier channel, because of course machine translation is not perfect either. And then I hear also this argument of like there is no data. We're so small countries, so few speakers, not enough data. Well, that's nonsense. Sure, there is data. There's plenty of data, but it's stuck in libraries, archives, media houses, publishers. Because copyright, because some reason, because always some small reason. What we need is to come together and figure this out in every country. But of course, for small countries, I think it would make sense to collaborate on this. But for some reason, collaboration is hard. I don't know, it doesn't work. Anyway, so that's the copyright part. Next problem, machines make mistakes. Well, so do humans. But the solution here is to take this error rate into account. And you should do that if you're using student assistance as well. And people do this thing where they calculate the COPPA score, and then they say, oh, this COPPA score was like 0.7, and that's it. But like, for some reason, there's very little discourse, almost nothing, on like, what do we do with that information? Okay, so we annotated, like, here are 3 people, they annotated data, the COPPA score is like medium. But now what? How do we incorporate that information in our actual estimates? How do we take that into account when we test our hypothesis on this annotated data? I don't know why people are not discussing this much when it comes to humans, but people are very interested in this when it comes to comparing machines and humans, because then it's like, but it's a machine, it's stupid, it makes mistakes. But that's easy to solve. There's a proposal in that preprint how to solve it in one way. There's probably other ways. But one way is just using basic bootstrapping. So use an expert annotated test set. You do like a few hundred examples. Then you maybe have you turn that into a confusion matrix. So ground truth and the prediction of the machine. And then you just simulate the annotation procedure. So for every example in the data, you sample from this confusion matrix, and you normalize it, and then you sample using weighted samples, and then you do it over and over again for hundreds of times, and then it gives you some idea of what your error is. You can build confidence intervals just using normal approximation, or maybe something more complicated. So basically, generate hundreds of versions of your data of these annotations, and if the accuracy is on 100%, then of course always the weighted sampling, it's going to pick the correct one always. If it's going to be like, I don't know, 90% time is correct, but sometimes the machine picks another one based on the test set, then it will also, this will be reflected in the samples. And then you have more variance, so you'll get a larger confidence interval. Easy. And this is also something we did with that. So you just put your confidence intervals around your coefficients or your time series or whatever you're interested in, or counts or whatever. Next problem, I have 10 minutes, but too many problems. So quantized variables are not modeled properly. So this is not the problem of AI, but this is just an application problem because humanities people sometimes are not particularly well versed in statistics. So in many paradigms, people do test hypotheses and get their results from just looking at variables. Not good. You can easily just bias your results this way. Quantified, annotated, coded data is quantitative data, so you should apply quantitative methods. If you apply qualitative or the sort of pseudo-quantitative methods where it kind of count but don't do anything else, is always a bad idea. You cannot reliably assess the reliability of the results. You cannot assess your effect size, your confounding variables. This is something you just cannot do qualitatively. It's literally humanly impossible. And also, what you have in humanities and social sciences, very commonly, is repeated measurements. But people are not doing anything about it. So let's say you do an interview with 10 people, and then you analyze these results, you have repeated measures. Because you have more than one statement from about your topic of interest from a single person, and there's probably more from one than the other, and you get bias. The bias you get can be this. So how many of you are familiar with Simpson's paradox? Yes, one. Okay, so every single person here should be familiar with Simpson's paradox. Google it, look it up. So this is an example of what happens if you don't control for repeated measures often, and what happens if you don't control for a hierarchical structure in your data. So here's a simulated example. Again, going back to the interview example with the students who like or don't like online learning. So the y-axis is age, and then these two box plots are sentiments. So here's negative, and for negative, the age seems to be lower. So if you just look at this black line, don't think about the colorful ones right now. If you just look at the black line, then it looks like younger people are more negative, and older people, slightly older students, are more positive. But that is actually not the case, because in the data, there are 3 schools. So you have hierarchical data structure there. And if you model that using, for example, a mixed effects regression model, then you will see that there is no effect, because it's just a matter of this school having older students, and they happen to be positive about online learning, and this school here having younger students, more on average, and they're being negative. There is no relationship between age and sentiment. But you will miss that if you don't properly model your data using the appropriate statistical model. Confounding variables are also a problem. So here is the same data, but simulated in a slightly different manner. So again, you have negative and positive sentiment. Negative is red. And in this example, the y-axis is meaningless. They're just like the points are just scattered along the y-axis. And these are off-campus students, and these are on-campus students. And when you look at them, then it looks like there's more blue here. So off-campus looks more positive, and more negative here. So on-campus people don't like online learning. This is just this univariate correlation, and it looks like, yeah, there is an effect there, right? Wrong. There's a confounding variable here, which is age, and if you do take into account age, then you can see that here in that simulation, it's an age thing. It just happens to be that there are more off-campus older students. Your effect disappears because you didn't model your confounding variable. So this is not a stats course, but why I'm talking about this is that people are very eager to jump on these opportunities offered by generative artificial intelligence. They see these papers where people they don't do the stats, they just do the annotation exercises. It's like, oh, look, you can just get the thing to annotate your data. But then they forget that if you do that, you also need to, if you have multiple variables, you need to do these things. If you have hierarchical data, then yes, you need to use mixed model or something. You cannot have one without the other, really. What else? I think I will have to leave a couple of slides, but actually the next slides are going to be practical anyway. Yes, okay, we're going to get into like very practical things anyway, so I will have to use like 5 or 10 minutes of the second half also on to talk a little bit more, but then I'll let you do stuff. Okay, so I'll have one more slide here, and then we'll go to a coffee break. So one still a more conceptual problem is that the machine doesn't do what you want. So what should you do? You give it a prompt, and it doesn't do what you want. And then what you do is the same as what you would do with humans. If humans don't understand you, then you talk to them. So you talk to the model, basically. You try different prompts. You should do it on a separate evaluation set, so you don't bias your results. But, I mean, you just make it work. And then you test separately if it actually worked. And maybe it doesn't. Maybe the problem is too complex. Maybe the language model doesn't support the language enough. Or maybe it does. You will find out. You will just figure out. And this is something you can technically kind of do on ChatGPT, for example. If you want to use the GPT models, I mean, it does perform differently, but yeah, you can get an idea of how it works, because there it's more optimized for chat, but you get an idea. Anyway, so after the break, we'll talk a little bit more about prompting. So how to prompt in a way to make the model work, and then you will try that actually, also how to do the prompting. Yeah, and then, oh yeah, okay, I have one more conceptual thing about transparency of research here. But then we'll get to practical things like how to actually use the OpenAI API, and how basically this is the amount of code that you need to write. It's not a lot. And I have an example. There are Colab notebooks that I'll give you a link, and you can just go there and run the code and see how it works. That's the plan. But now we can have a coffee break. How long should we have? 5 minutes, 10 minutes?
7 minutes.
7 minutes. Okay, so come back 11:07. Okay, so let's continue. So a couple of more things before we get started with a very practical thing. So how do you prompt your thing? So this is something you will be doing in like 5 minutes. So basically the most basic prompt you can do is, but often that is enough, is some instructions, and then your example. So here is some data, here is some text, do this thing. Is this sentence positive or negative? Here's the sentence, and this sentence is in Estonian. It says positive, because it says, I'm happy, better today. Does this text in Old Estonian contain any mention of food? If not, say no. If yes, say yes, and give me the food type. But in modern Estonian. And then this is something from like a few hundred years ago, and looks very funny. But there is a word for bread here, and it does recognize it's bread. Of course, there are more, if you read into this literature, there's more complex ways of prompting, something called chain of thought and tree of thought and stuff like that. Where you basically, because again, it's next word prediction. So you have the model kind of reason before it gives you an answer, and that usually gives you better results. But if you get like 99% accuracy already with this, then it's good enough. This is, as I mentioned, used for chatbots. You can just try prompts, and it gives you an idea kind of how it works. For example, if you're going to use the GPT API, then yes, you can kind of use ChatGPT. It's just, it works differently. So the sampling temperature is higher, so it gives you random answers sometimes, like more randomness. And it has some sort of system prompt in there, which makes it behave in a certain way, slightly different from the API. But you can kind of experiment. And of course, if you do experiment, then consider that these chatbots, they take the entire thread into their context window. So you just keep that in mind. Make a new thread when you try different things. You can also use the OpenAI Playground, but there you already need API credits, but you can buy them, and they have become really dirt cheap. I did make, and this I will put the link up there later as well. If you really hate code, then there's an option for you. You can do now in the remaining time, which is to use this sort of custom GPT. So this is something you could do on the pro version, the paid version of ChatGPT, but now this has been rolled out to free users as well, so you don't need a paid account. If you don't, well, all of you have a ChatGPT account probably anyway. You just go to this link and it gives you this annotator thing, and it kind of works. It's kind of hard to make these custom GPTs work iteratively, but I made it work. So you can put in a file and it will annotate it for you, kind of. But it's not an ideal solution. Another problem that you might run into is that maybe you have a huge corpus. You're lucky to have a huge corpus, but then running the whole corpus through an API is too expensive, or even like hosting a model in a cloud service where you pay per hour, it's still too expensive. So what do you do? I mean, there are various options. We also have a paper in +1 where we ran into this problem and we solved it. Is that you can do an easy search, like a quick keyword regex search beforehand, maybe do like a relevance filter, like, you know, distill your huge corpus into some candidate examples and then run that through an LLM and then do your analysis. So there are ways to optimize that. Or you could do something called RAG, which stands for Retrieval Augmented Generation. Has anybody heard about RAG? So if you want to make a lot of money, then just stop what you're doing right now and pivot into this. So this is basically a very easy way to do semantic search now. This was possible before, but just the language models were not good enough yet. But basically the way it works in the most simplest version is that you turn your documents into vectors using an embedding model, and then you turn your question, so a user asks something like, something, how did these things work in the 19th century? And then you compare the vectors. Vector comparison is super easy, it's just math. And then you use that to find the relevant examples. And then, of course, the generation part you don't need to do, but you can if it's more like a chatbot application where you summarize the found results using another large language model. This is kind of what ChatGPT does when you upload a document, for example. Of course, there's more complex ways of doing that as well. Some of you might be worried now with the examples that I'm giving you. The examples are, where are my examples anyway? Oh yeah, so when we're running these things, you know, you might be wondering still, but like, is this really transparent research? Maybe still a problem here. People sometimes say, oh, it's a black box. Like, I don't know how this model works. I don't know what it does. I don't know what it's been trained on. I don't know what the biases are in that model, which is very true. You don't usually know. There are no truly open source large language models right now. I mean, at that sort of level. Because mostly the training data is not shared because they're afraid of getting sued, and rightfully so. But, and pardon me the sort of whataboutism here, but how transparent is humanities research in general? So how much of humanities does open data, open code? How many of you do pre-registrations? How many of you share if you train a model, how many of you share it? Also, human assistants are also black boxes. Like, you don't know, you hire a student to do your annotation, but like maybe they're having a bad day. Maybe they secretly hate you. Maybe they're having a very good day and every single example is super positive for them. Is it less of a black box than using a neural network? And of course, cloud services people have been blindly using for ages to do data collection, surveys, crowdsourcing, happily using Amazon Mechanical Turk, putting all sorts of data there and nobody cares. Is it significantly less safe than sending your data to an API by Google or OpenAI? I don't know, maybe. But if you use this sort of machine-assisted quantitizing approach that I've been suggesting here, you can be actually quite transparent if you want. You can publicly share your data, if you can, your coding scheme, very importantly, the annotated data, either by you or a machine if you use the machine, the description of your statistical model, the parameters, code to replicate the model, so everybody can literally replicate your research, same data, same models, and so on. You can also, if you use the machine, you can either share the model version. Of course, these cloud models, yes, they change. It's a bit trickier. But you can still share as much as you can, so the versions, the prompts, everything. If you tuned your own little large language model yourself, then you can literally share the model snapshot, your version of the model on Hugging Face or whatever. So you can make things transparent if you want. And of course, importantly, you also share your training, evaluation, test sets, so people can actually evaluate how well or how did you do your analysis. For some reason, people don't want to do that in humanities a lot. They just want to kind of hide this part away. And then people wonder why the other hard sciences are not taking us seriously. Another solution to the various sort of transparency problems is using this sort of train, evaluate, test approach, which is this standard way of doing things in computer science. So what you do is you have training data, but in that case you don't really need training data because you're going to use a pre-trained model probably, unless you're going to tune your own model. But here again we're focusing on this specifically this zero-shot application, which doesn't need tuning. You have evaluation data, so in that case, in the zero-shot case, that's the data you try your prompts on, some examples that you have annotated yourself and then compare. And then the testing data, which again, you annotated yourself or some expert has done it, and then you compare the model results and you get an idea of what's the accuracy, what's the agreement. And of course, as I mentioned, the confusion matrix obtained from comparing these two, the test set and the human annotations on the test set, you can use to sort of simulate the confidence intervals. You get an idea of reliability. So getting now into like technical things. So if you're using these models, you probably want a specific output, not like a text of, hello, I am a large language model, here is your answer or something. You want probably like a yes, no, or good, bad, happy, sad, whatever, concrete answers. It's possible to do in many models using some parameter, might be called different, but basically you intentionally bias the outputs. In the OpenAI API, it's called logit bias. It's a parameter of the API. It's well documented. So you set high weight to tokens, which you want, and then it will give you one of these tokens. You give them equal weight, and then you get these answers. So in that API, if you use the Python package for that, then it's easy. It's just a dictionary. In this tokenizer, this index of 9,642 is a token for yes, and the other one is for no. So you say, okay, I want weight 100, 100% weight for these two tokens. I only want these words. You can find these tokens. There's another package for that, for these tokenizers. And then you can also set the max tokens to 1, because it's just one token, so you don't want it to go on talk long about its answer. So fewer tokens also means cheaper usage in that case of these sort of token-based APIs. But of course, if you want to use something like chain of thought, then this is not going to work, and then you need to parse your answer out of its answer. How to talk to OpenAI using their own Python package, which is called OpenAI, helpfully. Easy. So this is Python. For those of you who are not familiar with it, don't worry. So basically, you get the package, you initialize the client, you need the API key. This is something you need to pay for. And then you get the response by asking the client to do something for you. You just specify the model. Here I said GPT-4o. And then you send the messages. In your case, you just want the user message. And this is basically defined like this. Here's some content. Is the sentence about nature or natural processes? What a beautiful sunny day. I want a single token answer. Temperature is 0, so it doesn't do random sampling of the outputs. And the logic bias is yes and no. I think the tokenizer here is different, but anyway. So I want a yes or no answer, and that's it. And then from that object, you just get the content, and that's it. Now you have used a large language model. Yes, you might want to put some things around there as well, like sometimes the API times out, so you want to catch these errors, but basically, that's kind of it. So yeah, if you're using synchronous APIs and you want to protect yourself against timeouts and other errors, Sometimes it just complains. And also, this is a bit technical. Basically, yes, you can retry if it goes wrong, but this only makes sense if your temperature is not 0, but you usually want 0 temperature because you don't want randomness. But importantly for OpenAI, there is now the asynchronous batch processing API, which is literally half the price. Like the prices have been going down anyway. Now you can parse like entire books for just like under $1. But if you use the batch processing, then it's not only is it easier in the sense that you don't need to worry about timeouts, but it's half the price. Intelligence has become cheap. This does take a little bit of more coding and fidgeting around with it, because you need to talk to it in a slightly different way, which I think I'll just skip for now because it's getting maybe a bit too complicated. But basically what you do is you send batches and you get answers back in 24 hours. But in practice, you get answers in minutes. You send a batch and then you just check if it has completed, and then you download the contents. If you're doing that, then just refer to the documentation. It is quite well documented. But for today's practical part, we don't need to go into that. It's a little bit more complicated. If you use OpenAI, and again, I'm no affiliation, I'm not an OpenAI service person or like a advertising person, but it is a very easy option. So what you do is you go to their platform if you want to use it. You used to have 2 ways of billing, now there's only one. Basically, you just put some money there. You use your credit card. I think the minimal is like $5 or something. You put money there, and then now you have money there, and then as you use the API, it trickles away. And when you put money there, you get the key, and then that secret key is something that you send with the API request, and that's how it works. Super easy. You could use open models. Not open source, but they're open weight, so you can download them easily from Hugging Face or other providers. You can run them yourself if you have a beefy computer, or you can also run them actually in Google Colab, and this is what we're going to do now. So the advantage is that you can run them and you can tune them for specific tasks. You can train them on your data, but the disadvantage is that you need to run them yourself. And sometimes it's a bit tricky because they require certain kinds of inputs, and it's a bit fidgeting around, and there's often version conflicts between the packages. It's a bit tricky sometimes. Okay, so we're gonna now do that. So there's a bunch of options here that you can do, and I'll try to help you. I was asked to also prepare homework. Should I explain the homework now, or shall I just send it later? Like, what's the best way to do that?
Let's get to the practical part, because we don't have much time.
So maybe I'll just email it to you later. Basically, the gist is that you try to apply this quantizing design, and you try out a few prompts using large language models, or if you want, you can do it on ChatGPT. Just basically get into the sort of way of thinking in the sort of systematic step-by-step manner. And I only want like less than a page, definitely not over a page, just a description of what you did. Anyway, but then in that case, let's get to the practical part. So here's a bunch of links. I didn't send them to you, but they are just these very short links that you can just copy. So
Anders, can you copy this in Zoom or?
I'm not on Zoom here, but I mean they can do the same as you, and you can just copy it. tinyurl.com machine annotator. That's not a lot to type. That's going to be left on the screen for the rest of the session, so don't worry about it. And I can send you afterwards the slides if you want. So the options are, if you really don't like coding, then you can just use ChatGPT, basically. That's the custom GPT that I prepared. You can put your data there, and you can play around and see how it works. And it doesn't cost you anything. You can use the OpenAI Playground. You don't need to code, but you do need to generate the API key and pay a minimum of $5 if you'd like, but it's a good thing to learn how to do that. And then there's these Colab examples. So how many of you have used Google Colab or Jupyter Notebooks either? Okay, so some of you, not all. So it's notebooks. It's easy to use. I have one for using the API. Again, you need to copy your own key in there to actually use it. I have an example of the Mistral 7 billion model, 7 billion parameter model, and I have an example of Moondream 2, which is this tiny, tiny little model that actually works kind of nice. If you use one of these things, then make sure to make a copy because you cannot edit the original. So just click File and save a copy in Drive. I'll show you immediately how to do that. Okay, so here's, for example, the Moondream example. If you go there, then what you need to do is just click File, save a copy in Drive, and then you have a copy that you can edit and save, and it's yours. You can use the code however you want. Just to give you an idea how these notebooks work, so in the case of Moondream and Mistral, what you will do is just you will download the model, and you will run it, because there's enough resources in even the free version of Colab to run these models, actually. So you can run your own model. Make sure that you are connected to a T4 runtime. So if it's a CPU, then you just switch to change runtime. Make sure that it's a GPU resource, because otherwise it will be miserably slow. This will run out of credits at some point, so you can use it like a little bit, and then it will say, okay, now you're out of free credits, but you can use it enough for today. So both of these notebooks look the same, pretty much. So just to kind of quickly walk you through these things. The first block is installation, so we will basically install a couple of packages. This is what this code does, and then define the model, and then this code block downloads the model. So by running this, you just press Control and Enter, or I think Command and Enter on a Mac, or you can click this little button here in the corner. This will take like a minute of time, depending on the internet speed here, and this will download the large language model. Actually, I can get it to work while I talk. And then just run this cell as well. Just click the corner or press Control Enter. It will define a little function that will talk to the model. And here is an example. So here's an image. It's just something I uploaded in my Google Drive. You can also just find an image online and put the link here. And then to talk to the model, I use this answer function, which I just defined here. And it takes two inputs, which is the prompt and the image, because it's this multimodal model. It's I think a picture of a female astronaut, and then the prompt is please describe this image, and the model said that. In this image, there's a woman standing in front of an American flag, so on and so on. Another example is this art piece here. The question is, what are all the objects, items, and people visible in this image? Give me a keyword list, and it says building, stars, moon, water, and sky. It's a model that is running. Well, it's still on the cloud, it's on the Google Cloud, but you've downloaded it, and you can run it yourself on your own stuff. This is a very small model, so it's not very obedient. So if you want a specific output, you need to really steer it, give it very concrete prompts. It is mostly tuned for giving this sort of summaries, so it's not super great, but again, it is very tiny. And same with Mistral, you basically download the model, define the answer function, and then here's the input. Is the sentence negative or positive in sentiment? Give me only one of these two words, positive and negative. Sentence, I had a wonderful time today at park today. And then the answer is positive. And here's some more examples. I think some of them are in Estonian. No, I don't know. But yeah, here's a bunch of sentences, and then this is a little loop that loops through all these sentences. It gives a nice table of positive, negative for the sentences. So zero-shot sentiment analysis. And for OpenAI, it's again the same, but here you don't download the model because it's API. So you just define the client. You do need to set your key here. Here's a little helper function that just, again, run this block, and then you can do stuff. So you check the logit bias. You define, you get the numbers you need, the indices of the, so you can get the specific outputs. And then here's an example which asks in the sentence about nature, and is the sentence about nature, animals, or plants? what a beautiful sunny day, max tokens 1, budget bias is whatever you defined here. So basically, a bunch of options to play around with. Up to you. But you can also use this ChatGPT version of that if you'd like, which is, oh yeah, here it is. So basically, it has an example as well. So basically, what it tries to do is do annotation, and then to continue, you just press enter twice. So I've sort of pre-prompted it in a way that it starts doing things. If it stops, you press enter twice again. Kind of works. And in the end, it will give you a table. Right, so let's do stuff. And we have until, we have like an hour now until lunch. So let's do the stuff. Up to you. You can reorganize if you want. You can sit next to somebody who knows more Python if you don't, but you would like to. And I will try to help you. Select one of these options and just start from somewhere. Try doing something. You can try to also run your own data. There's examples in the Colab as well, how to connect to Google Drive, so you can just upload your own data. Let's try and see what happens, basically. So some of you have tried playing around with the custom GPT. So just to emphasize, the ChatGPT-based thing is a toy. It's not something you should use for actual research, but it's something you can just play around with right now. And then some of you already discovered that Mistral doesn't work, so apparently there's a version conflict. These things change very fast. That's the annoying thing about using these open source models, is that they change and the packages they depend on change very fast. So I fixed the Moondream, which also didn't work again recently, but apparently Mistral has also changed. So sorry about that. The Moondream example does work though. Right, but the homework. So let me quickly go through that, so in case you want to start. So basically, the gist of the homework is pretty straightforward. So it's to apply this quantitizing design, the step-by-step idea that I told you about. You can also refer to the preprint that I mentioned before, which is an archive, if you want to have a look again. Basically, try to think in this manner. That's the homework. So come up with either a real or hypothetical research scenario, and tell me how you would do it in this framework. How you would use machine assistance, and how you would quantify the results. Now, if you're not a statistician or familiar with statistics, then don't worry about it. And this is not really a statistics course, but just tell me what you would like to test. So is it more like a count? You would like to count prevalence? Or is it more like relationships, like correlation? Just give me an idea, even if you don't know which model, which statistical model specifically you should use. And then find a data set, or just imagine a data set that you would use. Just write, if you want to imagine a data set, just imagine like 10 sentences of something. And then apply all these steps. So unitization, so what are good units? Are units sentences, or phrases, or paragraphs, or what is a good unit for your research question? So you do need a research question, a hypothesis, or something. It doesn't need to be a large data set. Again, it's fine if you have 5, 10 sentences. I just want to get an idea of how you would do it. And try to translate your research question into 1 or 2 variables. So if it's, I don't know, counting some prevalence of something, then it can be just 1 variable. If you want to, let's say the research question is about the correlation or relationship between 2 variables, then I guess you need 2 variables. Try to do it yourself, and also try to do it using large language models. You can actually run it on an API, or you can run some model on Google Colab, but you can also just do it on ChatGPT or Claude or whatever. Just try to write the prompt. Like, here's a prompt. You need to do something like this with this example. Answer this, this, or this. Here's the example. Basically what I discussed earlier. So, and show me the prompt. Tell me how you would prompt the model, basically, or how you would prompt a research assistant. Same thing. How you would distill your research question into instructions. Here's a variable. You need to annotate it in this way. And And they should be quite short. I imagine like half a page, maybe 1 page at most of text. So it should include what's the data, even if imaginary. The research question, important. What are the units, what are the variables, what's the coding scheme, or prompts. What is the sort of intended quantification, what you would quantify in that case. And just a short summary of how did that experience go. Like thinking in this manner, thinking along the lines of this pipeline, how did it go for you? And if you tried it out on a language model or even ChatGPT, then what did the model tell you? Like what was your experience in trying to get a model to assist you? Now, just to reiterate again, I don't think that ChatGPT or any other chatbot is good for academic research. It really is not meant for that. And it doesn't behave in a way that is useful for that. But you can use it for sort of prototyping, let's say. If you want to actually annotate like, thousands of examples from a corpus, then either run it on an API, run your own model, or if you're not into programming, then get somebody to run a model for you. And also, if you're not into statistics, then make sure you get somebody to help you with the statistics when quantifying the results. That's for actual research. But for this little toy example, with little homework, just give me an idea how you would apply this sort of feature analytic quantitizing pipeline and how you would use machine assistance. Any questions?
What file format should we use to upload our homework?
I think they sent you like a form. You just make a Word file or a PDF file and just throw it on this form. Yeah, I think they sent around an email. I don't really care. I mean, just a page in Word or PDF or something. That's fine.
Yes, I just wanted to ask this about the deadline. So,
I don't know.
The basic idea of our summer school is that you submit everything on that same day. But the reason behind this is that so you don't have to carry the homework for next week. But this one, it seems to me like it will be really cruel to ask to you submit it tomorrow morning. But then the question is also, Andres, how long do you want to keep receiving homeworks and evaluate? And from our side, of course, we need to put a deadline of giving out the certificates somewhere middle next week. So we still have a choice, but what does it seem reasonable for you?
Well, I can tell you that I cannot. I'll be completely offline, cut off from everything starting Sunday. So, and I will be away from, like, completely unreachable for like at least a week.
So that would mean that Friday afternoon is the latest already, right? Or even today is Thursday.
Yes, I mean, you're with the guys who wanted the homework, so here's homework, but I don't know the logistics of that. I just came up with the exercise.
Yeah, it is true. Anders is not at fault here because the University of Latvia needs to give grades to students. This is why we need the homeworks and assignments, and you do not have to submit it if you are not applying for the credit points. It's just, of course, it's good that you look at the exercise and think of it, but it's not mandatory to submit it.
Yeah, this is only for credits, maybe.
Yeah, it is for those who need the grades. And a certificate from the University of Latvia. So there's a question about where to submit. We have one form for all 3 assignments, and this you can see in the preparation for workshops document at the beginning, in the header. Also, if you submitted your work already during the Python workshops, this is the same link. You should be able to find Andres' workshop there. And in case Andres will not be here anymore when you submit your work and you still need the grades and the credit points. We'll find a way how to evaluate it.
Yeah, somebody else can grade it. That's fine.
Just let's keep in contact about this and do not worry at all.
Yeah, I mean, that's fine if somebody else grades it. That's fine by me.
We'll make Mar to do it. He was so helpful today. No, I'm joking. Maybe he's not here.
Right, so I don't know, you guys can figure it out. Yeah, but any technical questions about the homework for those who do need credit and are going to do that? Okay, then we still have like 10 minutes. I have like one last slide in the end that I will kind of summarize and tell you a few more things. But so either you can start on the homework or you can just play around with more of these things. Sorry that one of these things doesn't work. And then I will try to walk around and try to help you a bit more, and then I'll summarize. So yeah, so 10 more minutes. So I think we need to wrap up. So just to sort of summarize. So I hope you got a little taste of what's possible with these tools. The way I see it, machines work well enough already for a number of things. They just need to be steered and instructed in a way. Of course, there's challenges, but also there's challenges in traditional humanities, and I think we just work to solve them. To anybody who tells you if you're going to go back to your institution and say, "Oh, I'm going to use large language models," and they're like, "Yeah, but they're black boxes," then just say, "Well, so are you." Large language models are just one type of machine learning, but they're pretty good right now, and they enable large-scale corpus work. You can scale up analytics to larger data. Yes, using open models is more transparent and maybe a better idea, but also current state-of-the-art models tend to be commercial and also don't always work for small languages. So you might have to use commercial models. That's just how it is right now. But importantly, I think maybe I should emphasize all this stuff that we've talked about today. This is not a proposal to replace humans. This is a proposal to augment humans, to allow scaling of expertise to bigger and representative data. So if you're an expert and you know how to annotate or how to analyze, do deep analysis of this section of this book, then you can now instruct a large language model, tell them all you know. Your prompt can be this long or it can be this long. The context windows are all now like thousands, if not hundreds of thousands of words. Every prompt can be quite long. You can literally distill your expertise into a prompt and have the model do it not for one passage of a book, but millions of passages. If you're interested in discussing further any sort of collaboration, courses, consultation, but also bespoke AI solutions for enterprise or companies, then feel free to get in touch. We do this both at my universities, both Tallinn University and Estonia Business School. We are both of these institutions are increasingly more open to cross-sector collaboration. We have already done at Tallinn University, for example, collaborations with a media house, with a government institution. So we recently won a national tender, like a procurement for an AI-related thing. So we're very open to doing these things as scientists, but also privately. I am also in the private sector, so if you need consulting or if your company or institution or library or university is interested in consulting services or a custom AI course, then just get in touch and we can talk. Anyway, so those of you who are doing the homework, I look forward to seeing your homework. I don't still know if I'm grading them, but I'm looking forward to seeing them at some point. But yeah, thanks for coming otherwise, and see you at lunch.